Hi everyone. In this video, I will show how to run federated reproducibility code. The federated reproducibility is used to investigate the predictive reproducibility of federated graph neural networks. This work is accepted as oral presentation at the Prime MICCAI workshop 2022. To start using our framework, first we will install an Anaconda environment to manage our packets. Second, we will install required dependencies such as PyTorch and scikit-learn libraries. Finally, I will show how to execute federated reproducibility on a simulated data. As a first step, you will download the Anaconda environment from the following website. Please download the latest stable Anaconda version that is suitable for your system. For example, in my case, I downloaded May 2022 distribution for the 64-bit Windows system. After the installation, create a Conda environment by typing the following command in your terminal. We will use this environment to store all required packets. After creating your environment, use following command to activate it. Then, use pip to install NumPy, Pandas, Matplotlib, Seaborn, and scikit-learn. To install PyTorch, installation command can change depending on your system. Please refer to pytorch.org. Then, install PyTorch Geometric. Installation command might change depending on your system. Please read the PyTorch Geometric documentation. Next, use pip to install medmnist. Finally, go to following GitHub link and download our federated reproducibility code. Before running the code, I will show you how the input data should be represented. In our paper, we use symmetric brain connectivity graphs, which are basically n by n adjacency matrices, and square images. There are two options for using the image data. The first option is that you can use the square images as inputs directly, which are represented by n matrices. Or the second option is 8 connected adjacency matrix of the given image. The size of adjacency matrices is n squared by n squared. Our code converts the given image to adjacency matrix if this option is chosen. You can set the option by a command line argument. For more details, please visit GitHub repository and read the instructions. To summarize, you should have n samples of square matrices that can be image matrices or adjacency matrices of images or brain connectivity graphs, along with their corresponding labels for the classification. When the dataset is given, it will be divided into H heterogeneous datasets representing local data of H hospitals. Each local dataset will have an approximately equal number of subjects. Then, different local models of different hospitals will be trained by federated learning and also with non-federated baseline learning. Finally, we will obtain the results such as accuracy comparison of all models with federated and non-federated baseline learning and reproducibility matrices of these learning techniques. Now, I will make a quick demo to show you how to run federated reproducibility framework. Firstly, open your command prompt and change your directory to federated reproducibility under project folder. Then, activate your Conda environment that already contains all required packets. You can create simulated data by executing simulate-data.py. Finally, you can run our federated reproducibility framework by executing demo.py file. As you can see, it started the training process. For more details about the framework, you can check our YouTube video on Basira Lab channel and also repository on GitHub.